All right, so we're gonna switch gears here. We've spent the last couple of weeks putting these together. We figured out what the degree of a polynomial was. We talked about how to write it in standard form. We added polynomials, we subtracted polynomials, we multiplied polynomials. We've been putting things together, adding, subtracting, but adding, combining, and multiplying polynomials. Now, we're gonna talk about taking them apart. It's called factoring. All right, so introductory here in the beginning, we'll go slow. I've got a bunch of examples written on the board. I would expect you to pause the video at each problem to write them down because it will take a little bit of space. Don't try to write them all down at once, all right? We're gonna spend 2 days on this, so you'll be in class, have a chance to talk to me and ask questions. Here we go. So if I give you a problem that looks like this, if I give you a filled in area problem, right? I gave you this. Could you work backwards to tell me what made this answer? What made this problem? So hopefully you think you can. So right here, I know if this has 12 and this is a 4x, I know that this has to be something that multiplies into both of those. So I can work backwards and figure out, well, what goes into both of those? 4 goes into both of those. If I work backward here, I got a 3x and I got a 12. I can work backwards and say, well, there must be a 3 out here because that's what goes into both of them. I wouldn't be a 3x because there's no x in this term, right? It has to be, you have to see it in both terms for it to work. All right, so if I go here, well, I can look at a couple of different ways. I see this square right here. I know the only way I can make x squared is for both of these to be x's. Or I could look at it I could look at these two together and say, what do these two have in common? So these two both have one x in common. These two both have one x in common. So there's got to be an x out here. So we're just working backwards. So I know that the width of this rectangle would be x plus 4. The height, or the side here, would be x plus 3. So I know that it was x plus 4 and x plus 3 that made this area problem, made this rectangle. Okay? Again, down here, let's do the same thing. What would make this vertical column right here? What would go into both of those terms? How can I work backward and find something? What would it be? Okay. It's got to be 5. Okay. What about down across the bottom? Notice I'm doing this the same directions here that we did the other ones, okay? Down across the bottom, what goes into 4x and 20? What's the biggest thing that goes into both of those? All right. So you might look and think 2, and you're not wrong. 2 does go into both of them. I would agree with you. So if I think about a 2 here, it's not the right answer, don't write it down, but let's just think about a 2 here, okay? And let's say we go about and finish our problem. What goes into both of these? Well, these two have an x in common. These two have an x in common. When you do this, you need to go back and double check to see if your answers actually multiply together to give you what you want. So these two do have a 2 in common, that's 2. But if I double check here, 2 times 5 is not 20. 2 times x is not 4x. So while it's true they have a 2 in common, it's not the right answer. Most of you, and I already said it, it's got to be a 4. Now if I double check, 4 times 5 is 20, 4 times x is 4x. Now I know I've found the right answer. So I have an x plus 5 across the top and an x plus 4 down the side. All right? See if you can figure out number 3. A little tricky there. All right. So you notice I'm going the same direction. I'm always doing this one and then the bottom one, the right and the bottom. You don't have to do that. So this one I'm approaching a little bit different because it's got that negative there, right? So if I look here, what do they have in common? -5. So in the back of my mind, I'm keeping that, right? I know that's a -5. Well, if that's a -5, I know that's got to be positive 3. So now, does that work out? Yeah, that works. It works here if I put the x's in. So if you've got a negative somewhere, it makes sense to kind of start there, get that set, and then kind of work to figure out. So I know I've got x plus 3 and x minus 5. Again, you see what I'm doing here? I'm starting with an area and I'm working backwards to find the length and the width. I'm factoring. If I multiply these together, I get this. We just did this last week. Multiply these two things together, I would get this answer. Okay? What if, all right, what if I tell you, I'm going to leave these two blank, okay? And we got to fill them in somehow. And I tell you that they have to add up to 14x. I ask you, what numbers could I put in there that it would add up to 14x? Well, if we keep in mind working backwards, there's a whole lot of ways I can add up to 14x. 13 and 1, 12 and 2, 10 and 4, blah, 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 blah. 15 and negative 1. There's so many ways I can add up to 14x. That doesn't give me a whole lot to go on. But if I come back to these problems, I know that these two numbers added up to 7, because 3 and 4 add up to 7, but 3 and 4 also multiply to be 12. So here, these two added up to be 9, because the 5 out here and the 4 out here added up to be 9. But the 5 and the 4 also multiplied to be 20. So I didn't tell you, but I also gave you this other piece of information. So the two numbers have to add up to 14x, but they also have to multiply to equal 24. So, can you think of anything that multiplies to be 24 and adds to be 14? (12 and 2). 12x and 2x add up to 14x, and 12 times 2 multiply to be 24. So if I know what these add up to be, and I know I've got my multiply number right here, I know my answers right away. Let's practice that a little bit more before we jump into the really fun part here. Can you come up with what numbers multiply to be 30 and add to be 13? All right. If you got them real quick, good, great, grand. If you struggled with this, don't focus on the adding part first, focus on the multiplied part. So the only ways I can multiply to be 30 would be 1 times 30, 2 times 15, 3 times 10, 5 times 6. So you focus there. Once you have that list, you can find your answer, 3 times 10. All right, see if you can figure out this one. So, a little trick here, you got to think. You might be thinking, 10, that's 2 times 5. But it's also 1 times 10. So 1 times 10 add up to be 11. All right, a little harder with the negative. See if you can come up with number 7. All right, so if I look here, again, thinking back here, it's 1 times 30, 2, 15, 3, 10, 5, 6. But those multiply to be positive 30. If I'm going to multiply to be a negative, one of the numbers has to be negative. So now if I know one of the numbers has to be negative and they add up to -1, those two right there add up to -1, 5 and -6. All right, we're going to use this. Keep this in the back of your mind. We're flying to the other side of the room. Scary, I know. I'm going to check to see that we're in focus here. And let's finish this conversation. So, again, a reminder. If we start with this then we multiply. X times x is x squared. I would multiply to get 6x. I would multiply to get minus 3x. I would multiply to get negative 18. And we wrote our answer. We would combine like terms. So that middle number comes from these two squares. It's the sum of the two squares. So now I can work backwards. All right, this is the actual work. All this has been stuff to kind of get your mind primed. This is what your problems are going to look like today. I'm going to give you the end result, and you're going to work backwards to the two binomials. So I know this fills in here. I know this fills in here. That's automatic. All right, I take my squared term here. I take my constant term there. What goes in here? Well, if I think about the example, these two numbers add up to the middle number. And, like we talked about back there, they have to multiply to be 15. So right now, I need something that multiplies to 15. You should write this down, and adds to be 8. Can you think of anything that multiplies to 15 and adds to 8? When you think of those numbers, you write them in here. The order you write them in does not matter. Put the x's with them. All right? So 3x and 5x. 3 and 5, do it. Then I work backwards like we did here. This is 5. This is x. This is x. This is 3. So our answer, this factors to x plus 3, x plus 5. Okay. Let's do one more. So they multiply to negative 21. They add to what? Negative 4x. What multiplies to negative 21 and adds to negative 4x? Okay. Hopefully you came up with negative 7 and positive 3. So then I fill them in. It doesn't matter which way you put them. You'll get the same answer at the end. And then you work backwards. You factor. So what multiplies here? Negative 7. That's positive 3. And they have the x's here. X plus 3. X minus 7. Now you may be asking yourself, do I need to write this down every time? Well, I have two answers to that. One, you may have noticed that the answers we got here are the exact same numbers that we got there. Yes, they are. Okay. Do you have to write this out? No, you absolutely don't. In a couple of days, we're going to be doing problems that are a little bit harder, and the numbers you come up with won't be the answers. So I want to have this groundwork so we can come back to this. But for these problems, you do not have to write that out. Absolutely not. So right here, what's my multiply number? They have to multiply to be what? Think about the chart. What would go in the bottom right corner? Negative 24. They have to add to be what? 5. Do you have to write the x? I write the x when I'm doing the chart, so I remember to put an x on these two, so when I'm working backwards, I remember I have to have x's here. You don't have to put the x on the add number if you remember how to write your answers, but understand where it comes from. So, multiplies to negative 24, adds to 5. Can you come up with those numbers? Hopefully you came up with negative 8 and 3. All right, so then I write my answer, x minus 8, x plus 3. Sorry, got that backwards. Plus 8 minus 3. Sorry. By the way, sign errors, biggest mistake on these problems. Very, very common. Be careful with your signs, all right? That's why I caught myself by double checking because I knew it had to add up to positive 5. Had my signs backwards. All right, so what's my multiply number here? Yes, some of you are asking, is the multiply number always that last number? Yeah, it is. Think about when we do this, right? When we multiply the two constants together, that's my multiply number. So when I'm working backwards, I take this last number and I say last number, only if it's in standard form. Remember, we got to write them in standard form. If they're all jumbled out of order, then write them in standard form before you do this. So my multiply is -12. What's my add number? What number's there? Yeah, you don't see it, it's a 1, so it adds to 1. So what multiplies to -12 and adds to +1? +4 and -3. Watch your signs. So there's my answer. All right, took a long road to get there. Hopefully, because we did, you have a good understanding and you can just bang these out. We're gonna spend this tomorrow also if you're still struggling. Good luck, get your work done.